truth. And you know, I had already 60 slides, so I was really afraid to put that issue again in this.
Yeah, okay.
But I agree, there is also a lot of technology on the local scale, and perhaps I should have added a slide that I really would like to have a move towards much more response and stimulation of local technology as a way to develop production. And in that case, that's why your second question is also related to it. You also need kind of policy making to stimulate that. So indeed, this is much more on the big technologies that I thought that was also the reason why I was asked to give some ideas on how that could evolve. And the alternative is, of course, to put much more attention to local technology. But that needs another lecture again.
Yeah.
But you're completely right. Thank you very much.
Any more questions also around this topic?
I think just two quick points. I don't know whether it's better to go back to the beginning, but there was the slide you had of the first innovation process, the linear innovation process.
This one or this?
One more. Go more. Sorry, we're nearly there. Go back. Back. There.
Yeah.
You know, when I looked at this, and having been a scientist initially, to me this is a linear model of product development. But your heading says linear model of innovation. I'm not sure that's quite the right title, because this is a linear model of product development, which is a linear process. But what's missing here is out of each of those steps, research, development, production, marketing, there are arrows of innovation flying out in all directions. So the linear nature is the product development. And then later on, you go on to explain how there's all this innovation coming out of this process. I guess my comment here is I would have titled this linear model of product development as opposed to innovation.
Yes, this model is especially on product development in, say, in a company. And you're completely right. This process of research can be extended and can also involve, you can put another stage before. For instance, you can put something like university research that moves to, the insights moves to companies or other institutes and so on. But, and of course, this is too simple. That is also my critic on this model. And that's why I put forward that other model, which gives much more diversity. And what I would, you know, what we have here is that we often do not see all these different varieties. We do not see all the things that really happen. We only see the end result, and then we construct a history of technology that looks so simple.
So that was the first point. And the second point was right near the end, the slide that you had up recently, where you said that the green or the gene revolutions replaces subsistence farming.
Yeah.
That was your third point. And we haven't experienced that in Africa. So in Africa, where smallholder subsistence farmers have adopted GM crops, they've done this in parallel to their subsistence farming. So if you go to Burkina or to South Africa to smallholder farmers, they're not replacing their subsistence farming. Their subsistence farming is critical to them because it gives them the food crops they like to eat. So even if they're growing GM maize, for them it's a cash crop. Next to the house, they have their own varieties of preferred maize for eating. So it's just a comment, and as I was listening to that, I was thinking, if you go to the Philippines, if you go to India, these places as well, GM technology has not replaced subsistence farming. It runs in parallel to it. It provides a cash crop option.
It's difficult to discuss on concrete examples, of course. If you say we do not have such a process in South Africa, for instance, or it did not happen in Burkina Faso. What I said here is what is said by critics of biotechnology, and it might happen. You know, I think we are just in the beginning of the gene or the biotechnology revolution. I'm really curious about how the situation is in 25 years. And then, what you see for instance, in Western Europe and in the United States, but especially in Western Europe, and that's also my own experience as the son of a farmer. A lot of small farmers disappeared because of the bigger scales of the other farmers. Some others had to disappear, and that is not that need not to be a bad situation, because it's perhaps a natural evolving situation. But what happened in Europe, that replacing small farmers by big farmers was possible because there was a lot of accompanying new employment for all these farmers. My brothers were farmers, and they stopped later on when they were in their 40s, because it was not possible for them. But they got another job. But in a situation where there are not alternative employment possibilities, then we have a problem. And I'm a little bit afraid that that might happen if development of biotechnology goes too fast and too big. But I'm just guessing now, but that I think is an important thing, and that also stresses that such a development as the rise of biotechnology should be considered in wider context.
Okay, can you comment on core innovation process as it relates to genetic modification? Core innovation. Because my take it.
I don't know the core. I do not know the core innovation to it.
Okay. What is happening now with research for development is that people are pushing for an innovation process where the users have an input during the innovation of a technology, during the process of development of the product, the development of the product process that we saw
you
in
mean
one
involvement
of
of
the slides.
stakeholders?
Yeah, so the stakeholders have inputs as you develop that product. But this apparently there is a discussion that this is not possible with genetic engineering, because it's high technology, and what you get at the end is a product that you then, and in this case, product is equating technology to seed, which has the gene input in it. So in other words, the definition of technology in this case is that the seed that has the gene in it is the end product that you get to the users. Do you see this possible, that there is a possibility of an input during a process such as this, which is highly scientific?
I think that is a big problem you are touching now, because if you want to have stakeholders involved, and what you call core innovation, and what Guido Ruijkamp mentions as tailored biotechnology, I like the term because it stresses that you should tailor your development of your new technology, your new varieties, to the needs and the wishes and the requirements of a local level, on local farmers. But I think it's so difficult because of the system we have now, the system that only the big companies are able to develop the new traits in new crops. And so there is not a public system as we had with the Green Revolution. And that is the problem. So that has also to do with how do we construct, how do we build up an innovation system. And that is a political issue, of course. And we should solve that issue. How can we make technology, science available for local farmers? And that requires a quite different role of the big companies. Now, I would like that we should have such a system, but it's very difficult to do. Well, we agree, I think.
Okay, a question from here. Any, and then Professor.
My question is more on the slide where you ask how do we do it better? And I just wanted to say, like, I was in a situation where we interviewed some farmers in the northern areas of cropping regions in Namibia. And most farmers, they maybe might appreciate technology, but they also like to keep their traditional practices. That means in terms of conservation of seeds and whatnot.
Mm-hmm.
And then now you get this new wave of information where they are talking about climate change issues. And people are telling them it's better because of the poor change in the climate and the climate variability. It's better to keep your indigenous varieties or the land races with respect to mix than to go for hybrids and to keep their practices. So now it's kind of like there's already a conflict somehow, because it's like you want them to enter this with gene revolution. They haven't really experienced the green revolution like they really say, because most of the subsistence farmers, they follow their cultural practices, they still use draft power, and now also the people encourage them to continue using draft power instead of this carrots that are not sustainable for the in terms of tillage. So it's like a message taking them kind of backwards as well. So I don't know, because you asked how do we do it better, because now people are pushing for more organic farming, certain people. So
yes, how to do it better. Well, first of all, I think we talk about biotechnology in the sense of genetic modification, and I would rather like to have a wider definition of biotechnology, say the involvement of modern insights on molecular mechanisms into breeding. So from that point of perspective, you can say that marker-assisted breeding is also a kind of biotechnology. And in that sense, biotechnology can even, in my view, contribute to organic farming by helping them to develop varieties that match better to the conditions and that perhaps can. So that also means that biotechnology, in this sense, can contribute to the subsistence of the local varieties. They perhaps can improve these varieties. For instance, if you have a local variety that is very sensitive to a certain disease, blight or something like that, and you can make that variety more resistant by using biotechnological techniques in the sense as I described, then I think we have progress, and then you can, in a certain sense, you keep your own varieties, but you can improve your varieties. Because also the old varieties were improved in all the centuries. So why shouldn't you go on with that process of improving these old varieties, making use as possible from modern insights? So there's, in my view, there need not be a very principal contrast between old and new technology. I would like to mix them and to use new technology as far as it can help the old systems.
Thanks. I think my main discussion would be on the 2 points that Mafi and Doreen made earlier, but I just want to jump quickly back to right in the beginning where you started the discussion, looking at the impact of science on society and all of those things and the reasons why it's important. I think the one thing that one should always, again, put in the back of your mind is also look at the impact of no science, of course. I know you do those kind of things. And I think the atomic or the nuclear bombs is a good example, because obviously, it's hugely impact and, what's the word, the sad part of our history. But what's difficult to do is to compare that image of Nagasaki, for example, with what would have happened if we had a Second World War that was drawn out in a completely different society. So it's a very difficult thing to do. It's easy to look at one particular thing that has a highly emotive and negative connotation in everybody's mind, and then make it a poster or in a very complicated thing. And I don't want to make a discussion about it. It's just that it's difficult to do it in society. What I actually want to talk about is quickly touch on what you said about subsistence farming, but not in that direction. One of my big arguments is that one of the huge powers of gene technology, and this is my primary basis for support of it, is that it can make a difference in somebody's backyard. So we can use the technology to change people's lives in a completely different way. So it might even in some ways increase this kind of subsistence farming in my mind, because you have, at the end of the day, it's about better cultivars of crops. And then the one other point that you made somewhere is on technology changing knowledge and culture, which of course it does. The only problem I have with it is that sometimes people look at it in a negative way. And this now, in my mind, intertwines very tightly with this risk-benefit issue. Because of course technology changes our lives, and it's one of the roles of technology is to change our cultures. I think it only becomes controversial when we don't really see the benefit of it. And you know, I want to touch on what the colleague there in the back row said earlier today. It said we must just leave it until people see the benefit, then they will come to it. And until there's not a benefit for them, obviously it's their choice not to use it. But we should not be afraid of technology because it has the potential to change our lives. In the end, it's your choice if you want to make that difference, but I would love technology, and I do love technology that's changing my life on it. And my culture, I mean, my culture is completely different than my dad's culture already, and it's one generation. So we mustn't look at this as a protectionist kind of thing. It's individual's choice, but it can be a very positive thing instead of a negative thing.
Great pleasure to be here. Ida and I met at one of these workshops in 1999, and I remembered who the third person was in our taxi, Grace Titai from Kenya.
Oh yeah.
Yeah, so it's wonderful to be back here. There's been a lot of effort in Namibia to build a biosafety process that is responsive to the needs of the citizens. And I'm really pleased that other countries in SADC are coming to learn about that process. So this particular talk, I thank the African Biosafety Network of Expertise. They asked me if I could come and give this presentation, and specifically about appropriate biotechnology for Africa. And what we're finding is that the regulatory systems around the world are evolving. They're getting more complex in many cases. In other cases, they're actually simplifying. So we heard last week at the ISB GMO meeting in Cape Town that the Canadian government has now identified familiarity with certain genetically modified crops. And it has reduced the regulatory burden on them down to just a few pieces of information they need before a permit is issued. So, in Europe, we're seeing an explosion in complexity of their regulatory system. In some of the other countries, we're seeing a rationalization in what is required for safety. And so I think this talk is very appropriate because as African countries, you can leapfrog, as you did with cell phone technology, into the most appropriate regulation for your country and your people. That's what I'd like to address. I'm actually not going to talk. I think I've got 5 slides. I don't want to talk too much. I want us to try and exercise to illustrate appropriate regulation. So I'm going to talk about what is appropriate. I'm going to talk about some of the current issues that I've heard from the African debate, some of the possible solutions, and then we're going to do a group exercise. So what is appropriate? To be appropriate regulation in Africa, it has to be effective. So as a regulator, your job is to encourage the safe and responsible use of GMOs in your country. So we're not saying make it simple so it's no longer effective. Whatever you regulate, you must be an effective regulator. If there is hazard, if there are safety issues, your appropriate regulatory system must be able to identify them and address them. The system has to be affordable. As African countries, we don't have FDAs and APHISs and EFSAs, these huge regulatory structures that first world countries have. We don't have them, and I don't think we're ever going to be able to afford them. So how do we design a regulatory system that is affordable for our countries? It also has to be sustainable. So a good example is Kenya. They put together their biosafety framework. It looks great. They created their National Biosafety Authority. The National Biosafety Authority over the last 4 years has had one application for confined field trials, and they've realized this is not sustainable. We have this huge authority, 5 full-time people, an advisory committee of 30 scientists, and a board of 20 people, and we reviewed one application in 4 years. So how do you make a regulatory system that is sustainable for your country? It also has to be something that is applied easily, not too complex, use the resources that you have. And it's important to balance the risk with the resources. So if you have a very potentially risky application, you want to be able to pull in all your resources and make sure you manage the risk effectively. If you're working with a GMO application that is something that is very familiar, maybe you've run it through 7 years of field trials, and your scientists understand this GMO, and they understand the risk, then the resources you use for the commercial application do not have to be as extensive. So how do you balance the risk with the amount of resources that you need? And then take into account the demand. So Kenya is a good example. If you're only going to be reviewing three applications a year, don't create a huge state structure that you're paying for that really does not have enough to do. Some of the current issues, there was a big discussion at COPMOP about terminology. There's a group pushing that's saying as we come to new breeding technologies, cisgenics, all these interference RNAs, we have to revamp risk assessment to be effective. And that's not the case. Risk assessment wasn't developed for biosafety. Risk assessment has been used long before GMOs ever came on the market. And when GMOs came on the market, regulators looked at the risk assessments they were doing for biocontrol agents, for pesticides, for biological weapons, for medical applications, and they adapted the risk assessment process to be effective for GMOs. We don't need a new process. We don't need new technology. Each of these technologies can fit into our existing risk assessment process. What we need is to become comfortable with risk assessment. If you're regulators, if you're scientific advisors to regulatory authorities, you need to be confident that if you use risk assessment, as has been described to you over the last 2 days, you will be able to make good decisions. Affordability. In the 1990s, I think it was in about 1997, regulators got together on a discussion, and they felt that GMOs would eventually merge into new hybrid release and a release of new varieties, just as any other public sector crop would have. In 1999, activism started against GM technology, and that changed the playing field. Just as regulators were starting to get comfortable that risk assessment was effective and they could manage risk, the activists came in and they changed the playing field. And so instead of GMOs just merging into hybrid development, as one of the questions was earlier, they've now become an issue. And as regulators, we have to address those issues. That's our job. So as a result, the requirements for regulation have grown. They've got more and more and more. Initially, risk assessment was focused just on safety. Then came the issue, what about socioeconomic impact? And that is included. And slowly issues have been added, and there's more and more research for developers to do before they can submit an application. So what we saw in South Africa was in 1997, we had applications on 15 crops from the public sector, in addition to applications on 3 crops from the private sector. Once our regulatory systems became more complex, the data requirements became more complex, the public sector research on the 15 crops, which you could call orphan crops, tapered off to nothing. Now in South Africa, the amount of public research we have developing GM crops for smallholder farmers is extremely low. And it's all about this affordability. Oops. There's that button. Issue. And then accessibility to the regulatory system. In Africa, most of what is being done at the moment is technology transfer from other countries. And they are very skilled, the developers, the multinational companies, at regulatory systems. They have good resources. The regulatory process is very accessible to them. But the exciting thing is in Africa is that we also have a lot of local development of new GM products. We have cassava, we have cowpea, we have maize, locally developed drought-tolerant maize. We have new crops coming in that are developed in Africa. But what we're finding is that these groups are not, the local development groups, are not finding our GM regulatory systems accessible. In a sense, we've developed our GM regulatory systems to regulate multinational companies with lots of resources. And those are our data requirements. Then our public sector researcher comes with a maize streak virus-resistant maize and wants to run a field trial, and they look at the costs involved and all the studies that have to be done, and they simply can't do it. So when we're talking about appropriate regulation for Africa, we need to rationalize what data we're asking for. Why are we asking for this data? Do we need it? How will we use this to assess safety? And I think we will discover that we would be able to make our regulatory systems a lot more accessible if we rationalize what we require for regulation. One of the new issues is socioeconomics and decision making. I've always been in favor of this since 1999. I think I even talked about it then. I think it's critically important in Africa that we always relate our decisions to the impact on society, but socioeconomic input also lets us look at benefits. And this is where we have to weigh the benefits against the risks. And I think Henny made a good point. One of the questions in South Africa that we always asked was, what is the impact if we do not approve this product? So you have to look at benefits as well. I'd encourage you to do that. And then one of the current issues is food and feed imports. We've seen what's happened in Kenya. They've had all sorts of problems. So I'm not sure of all countries that are here, but maybe you just tell me, which of you live in countries that import genetically modified food?
But if you ask feed,
No, I'm asking food, specifically. Okay, which of you live in countries that import genetically modified feed for animals? And in fact, I would argue that all of you have to put your hands up, even the Europeans for food, because the Europeans are using genetically modified enzymes to make their chocolates, etc. There's a lot of use of genetic modification in food production. So we're all importing feed, definitely, that is genetically modified, and I would argue that we're all importing food components as well. Are we regulating them? How many of you live in countries that regulate the import of GM feed? How many of you live in countries that regulate the import of GM food? Okay. So we have to come up with appropriate regulatory systems to regulate the things that we're already using. And it's a good starting block in our regulatory process. So how do we address the fact that we have burgeoning regulatory systems that are becoming inaccessible and unaffordable to our local African developers? And the first one is that reviews should be commensurate with the risk. What do I mean by commensurate? If there's a lot of risk, you need to do a very thorough risk assessment to find the answers. If there's low risk, and if there's familiarity, let me use the term, I was glad to hear it, then we should come up with a fast-track review process that identifies any unique risk to this product in our country and make our regulatory systems more accessible, more affordable, more sustainable. I also think that we would benefit from regional reviews and regional decision-making. That's a whole new ballgame. That was all I wanted to say about appropriate regulation. And I thought the best way to illustrate what I've been talking about is for us to go through an exercise. Let's take two examples. I tried to choose one which I felt was low risk, and maybe you're going to convince me it's not low risk. First one's going to be BT cotton, and I tried to choose an example that is potentially higher risk, and that would be an Ebola vaccine made in maize. And I thought we'll go through a quick risk assessment process and see what we think of the regulatory approach to these two products. So Henny came across very clearly. What is our risk assessment process? For each one of these two products, we're going to identify our concerns.